Alright guys, Mr. Bragging back here to talk about how to calculate for acceleration. I just talked to you guys about how to do the ticker tape timers and understanding that visual representation of acceleration. In addition, if you check out there's another video that shows you how to go from a distance time graph, velocity time graph, to an acceleration time graph, so you should have a pretty good understanding of visually representing acceleration and interpreting visual representations of acceleration. So the next thing we need to do is talk about how to actually calculate that acceleration. So again, average speed or velocity is distance divided by time. We talked about that. Make sure you've actually watched that video in the last unit about how to calculate for velocity, because I talk about a lot of the very basics of how to calculate in science. It's going to be the same way with mostly pretty much every single problem that we do. Again, I call that process plug and chug. There's a few steps to it, but overall, remember, you're trying to figure out what do you need to know. You need to know average speed or velocity, what equation to use to find that. Velocity is distance divided by time. Find the missing variables, so in this case distance divided by time. Find the values of those two, write those down, plug them into the equation, and then do the math. Alright. So again, they give you another little sample problem of the same thing here of the velocity. So here they give you distance, time, velocity, distance divided by time, plug in the numbers, do the math. Now, acceleration, on the other hand, again, you do the math very, very similar, except instead of it being distance divided by time, acceleration is the velocity, or change in velocity divided by time. These little triangles that you see here mean change in. And so what you're looking at is, where did the velocity start at? And where did it end at? So let's say if you have a car that's going to get on the highway, they start at 0 and then they get 60 miles per hour, it goes from 0 to 60. So that change in velocity would actually be 60 in that case. Alright, rewind and replay that a dozen times if you need to, because I explained a lot in that one sentence. Alright, so here we go. Here is the first acceleration problem. So get my pen here. So acceleration equals change in, a little delta sign, change in velocity divided by the time. Alright, so we need to know change in velocity, and we need to know the time. So let's read the sentence here. It says it begins moving forward, is stopped on a straight path. Okay, so we know it starts at 0 if it's stopped. Begins moving forward and reaches a full gallop along the path in 10 seconds. Alright, so they just gave us the time. The horse gallops at a speed of 20 meters per second. Okay, so it started out at 0 because it was stopped. It got up to 20. So we take the final velocity, meaning where did it end at, and subtract the initial. We need to find the difference between this number and this number. Where did it start compared to where did it end at? And that change was 20. So the velocity change was 20 meters per second. Okay? So, again, plug and chug. Acceleration, change in velocity is 20 divided by 10. Put the units in there, 20 meters per second divided by 10 seconds. So acceleration equals 20 divided by 10, we get 2. 2 meters. So the change in was 2 meters per second every second. So we put in 2 meters per second squared. So this equation involves a little bit more work because you're actually looking for the change in velocity. You're not just looking for the velocity. Make sure, again, you're looking for the change. Where did it start compared to where did it end at? And again, follow those same principles of plugging and chugging, where you find the equation you're going to use, you write down the values of all the missing variables, you replace the letters with the missing variables, and then you solve the equation. Rewind 15 seconds and play it again and again. That way you get notes for that, because if you miss any of those steps, it's going to be very, very difficult for you to solve any of these problems. And if you listen to it again, I guarantee it's going to help you out. Erase all the markups made real quick. Kind of thinking that this is the end of this lecture. But overall, again, same as finding velocity. You plug and chug, follow those same steps every single time. It's going to give you a few more equations here. And again, you do have to solve for acceleration here. Be able to calculate acceleration when given a scenario or visual representation. In visual representations, you might just have to use those visual representations to gather the same data. So again, if you're calculating for acceleration and the graph shows that, oh, it went from 0 meters per second to 10 meters per second over 2 seconds, you can use that data to do a calculation. It's very, very simple to do. You're just having to use the graph to retrieve the information rather than a sentence like this. Okay? And that ends it. So if you have any questions, make sure you write them down. Other than that, see you guys next time.